brief review of circles. Remember, a circle can be defined as the set of all points in a plane that are a fixed distance from a fixed point. So what that means is, if we draw a picture and we call this fixed point right here HK and let it be the center, we can find all the points that have a fixed distance from that point, and we'll call that fixed distance R for radius. So let me draw a circle, close to a circle, and we'll say this distance right here is R for every point XY on the circle. That's how we define it. This distance is constant regardless of what point we find on the circle. So to find the equation of a circle, remember the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. We can just use that for this particular problem, substituting in R for the distance and substituting in the points HK and XY for these 2 points, for the points X1, Y1, and X2, Y2. So we have X minus H squared underneath this radical sign plus Y minus K squared. And we have the equation of this circle, but we don't usually present it this way. Normally, we square both sides so it looks a little bit nicer. So we have X minus H squared plus Y minus K squared equals R squared. And in fact, usually they're written the other way around. So let me write it right here underneath this circle. We have X minus H squared plus Y minus K squared equals R squared, which represents the equation of the circle that is centered at HK with radius R. So if we were just going to state the center and radius, and we're given the equation in standard form, something like this, x plus 5 squared plus y minus 11 squared equals 25. If it's in standard form, the center and radius are practically looking at us. It's the opposite of this number. Remember, it's x minus the x coordinate of the center, so it's x minus negative 5. So our center would be at negative 5 comma y minus k, or y minus 11. So our y coordinate of our center is here. And our radius is equal to the square root of this number. So our radius is equal to the square root of 25, which would just be 5. Let's do a few more. So the directions are state the center and radius. And it could look like this: x squared plus y plus 4 squared equals 8. Another one that's coming in standard form. So with this one, we look here for our x coordinate of the center. Notice there is nothing that we're subtracting from the x, so in fact that means it's really x minus 0, so 0 is the x coordinate. The opposite of this number would be negative 4. And our radius is the square root of this number, because this number is the radius squared. And it's the positive square root. Our radius is always positive. And of course, we would simplify the square root of 8 and make it 2 square root of 2. The equation could look more like this. Let's do another one. Let's make it 4 times x plus 1 squared plus 4 times y minus 87 squared equals 11. Now this one isn't quite in standard form, because remember, in standard form, let me show you again, the coefficients here were 1s. And here we don't have 1s, but that's okay. We can just take one step to divide both sides by 4. And now our equation will be in standard form. It's x plus 1 squared plus y minus 87 squared equals 11/4. And again, our center and radius are practically looking at us. The center would be the opposite of this number, comma, opposite of negative 87 is positive 87. And our radius is the square root of this number. Square root of 11 is, well, just the square root of 11. And the square root of 4 is 2. So I would write the radius as the square root of 11 over 2. Let's do one more problem. Same direction. State the center and radius for the circle that's going to be represented by this equation. So here's the equation. It's x squared plus y squared minus 18x plus 8y plus 47 equals 0. You'll notice this is not in standard form and not even close. Our goal is to make the equation look like this. Notice these are both perfect squares. So our job is to complete the square with respect to x and with respect to y. So let's rearrange the terms. We'll put the x's together and we'll put the y's together. And this 47 I don't really need on this side. I just want these two perfect squares. So let's subtract 47 from both sides so it ends up on the other side. And now we're going to complete the square. So we take half of 18, which is 9. 9 squared is 81. And remember, it's always a positive number that you add when you're completing the square. So I add 81 to both sides. Similarly here, we take half of 8 is 4. 4 squared is 16. So we add 16 to both sides. And we write this as our perfect square. So we have x minus 9 squared plus y plus 4 squared equals, and over here we need to do some arithmetic. Let's see, that's 97 minus 47. What's that, 50? So our equation is now in standard form, so we could state our center and our radius. So we have 9, negative 4 for center, and our radius is equal to the square root of 50. Again, that can be simplified because it's 25 times 2. So we have 5 square root of 2. So given any equation of a circle, you should be able to put it in standard form and be able to state the center and the radius.